So, good evening, all of you.
Good evening.
Let me share my screen. Yeah, okay. So, only Mr. Mohan was there yesterday. Uh, the rest of you were not there. So, maybe I could just quickly tell what was discussed yesterday and then come back to this topic. So, it was like this. I'll just show you one figure and explain the complete thing. Like we were talking about I mean to say, in this particular subject, you have several things like data mining is there, then DBMS is there, XML is there, many things are there. We have started with data mining. And data is abundantly available everywhere. We have to mine knowledge out of data. For that, we use data mining techniques. And where do we store this data? We store the data in the data warehouse. In the data warehouse, just data is dumped. It just stores old data, like data is never updated. It just keeps piled up in the data warehouse, and it stores subject related data, and the data is non-volatile. Uh, so that is how data is stored in the data warehouse. Now from this data, we can perform analysis by picking up data using some functionalities. How? By using data mining functionalities. So you can just see this figure. Like we have this figure where we find various databases from which data is collected, pre-processed, and then stored in the data warehouse. The information of what data is stored in the data warehouse must also be stored somewhere. Like if I'm storing the age of someone, then I should be telling that the age lies between a particular range. But if it is a school, the range would be from say 5 till 15. If the school is till 10th standard. But if it is a college, the age cannot be from 5. The age has to be from maybe 17 till 25 and not more than that. So depending upon the organization, depending upon the situation, we are going to store the data and the information related to the data. So that data about the data is known as metadata. So that is important in order to understand the data that we store in the data warehouse. So that is called metadata repository. So in this bottom tier, we have the database, data warehouse servers, and as well as a subset of the data warehouse called data marts, as well as metadata repositories, as well as monitoring and administration part of the data warehouse. Data warehouse is a huge thing. So we need to administer it, and there are some softwares that are going to perform the administration as well as monitoring of the data that gets stored in the data warehouse. Now, simply storing the data in a data warehouse is of no use. There must be some analytical tools which are going to analyze the data and extract knowledge out of the data stored in the data warehouse and present it to the user. So that is done by the middle tier, that is the OLAP servers. OLAP means online analytical processing. And these servers, there are multiple servers in the middle tier. These servers are going to extract the data as per the need of the organization, and then they are going to present it to the users, that is this top tier. And how are they going to present it? Depending upon the need of the user. Maybe in the form of query reports, maybe in the form of charts, analysis, or maybe in whichever way it is required. So this is what actually happens. Now let me show you another diagram. Here is the one again. The same thing. We collect the data from the databases. pre-process it, which includes cleaning, integration, selection, and transformation. Why? Because data is collected from multiple sources. So multiple sources data will be in multiple formats, and data will not be perfectly placed in the databases. So it has to be cleaned. Sometimes if it is incomplete, we have to fill it up in some way or the other, and we have to bring the data into a single format that we require. That is a format that is used in the destination but not at the source. And finally, data mining techniques will be used, and then the data will be picked up, and the data that is of use to us is called as patterns, and we are going to retrieve the patterns from the data warehouse data, and those patterns are evaluated to check whether they are really interesting or not. And based on some criteria, we will say if they get this many marks, then they pass, otherwise not. So similarly, there are some interestingness measures. We will these patterns have to go through that, and once they pass that, they are going to be presented to the user. Okay, so that's the one. And uh, please interrupt me whenever you don't understand. Okay. And this whole process is called knowledge discovery in databases. Why? Because in databases, data is stored and we are going to discover knowledge out of it. So that process is called knowledge discovery in databases. And these are the things like the middle portion in that complete KDD process was data mining. So what are we going to perform in data mining? The characterization, discrimination, and all these things we are going to perform. And throughout the data mining, we are going to study what is characterization, what is discrimination, what is classification, clustering, etc., and several algorithms related to that, which help us in performing that particular data mining task. Okay, so this is what we have discussed yesterday. I've told it in brief. Uh, so we will move on to the next thing, next important thing I'll tell you. Okay. Yeah, see, this is association rule mining. One of the characteristics or one of the functionalities of data mining was association rule mining. Now, what do we mean by association rule mining? So in association rule mining, we are interested to learn which two products or which two items are closely associated and how much they are associated. Okay, so what is it all about? So here, what are the things we need to know, and what is a very popular algorithm that is to be studied under association rule mining? See, this I is a set consisting of all the items. Okay, I1, I2 till IN is a set of items. Okay, now D is a set of transactions. It's a transaction database. Okay, now here, this is an example. Items means milk, bread, butter, beer, etc. Now, transaction means, say, in one transaction, maybe I have gone to a shop and I have just purchased milk and bread. That's it. So one and one we have put. So, but next time when I went, I just bought butter. The third time I visited the store, I bought beer. So whoever may be, that whenever a transaction has happened by someone or the other, during the first transaction, they have bought milk and bread. Next time they bought bread, and this is how it is represented. Okay, either in the form of this, or it may be represented directly by the names, like transaction 1, milk comma bread, that's it. Transaction 2, butter only. Then transaction 3, only beer. Then transaction 4, milk, bread, butter. So anything may be written, but easily it could be understood that these were the items that were bought together in a particular transaction. Okay, now this is a transaction database. Okay, in a particular transaction, how many items were bought together? We can represent it in this way, or writing the names of the items separated by a comma. Now, what does this mean? This is a rule, association rule. What does it say? It says whenever butter and bread are bought together, it implies that milk is also bought along with them. Okay, so I think this notation is clearly understood. Whenever bread and butter are bought, it implies that milk is also bought. Okay, so customers also bought milk. So how much? So we have suppose 100 transactions, and we have found this so many times. So we have to find out the probability. So if we find that the probability is more, so accordingly we can change our plans. Accordingly, we can change our plans in placing the items in the store. Say, for example, bread is placed at one shelf in the store, and butter is placed and jam is placed at a far off place. Then what happens is people don't see the jam and butter in front, so they don't feel like buying. And sometimes it might so happen that uh, if it is not placed in front of or nearby the bread, they feel that itna dur jana hai, why to go and waste time. And sometimes if you place those things that go well with bread near bread, they might be tempted and want to try new things. So those things get they might get more of sales might happen for those items. So these things actually, which things are bought together, which things are not, will actually help you to increase your sales and maybe to improve your sales. So that is why this particular analysis is important. Okay. Can I get a response? Are you people following?
Yes, ma'am.
Okay.
Yes, ma'am.
Fine. So we have some, I mean to say, two measures. Okay. So one of the measure is called confidence. Okay, the confidence. Now, what is the definition of confidence? What is the formula for the confidence? This is a rule. Okay, this is a rule. This is how we have written it. This is a rule. Okay, so x is on the left hand side, so which means that if we buy this, which implies that we also buy this. Okay, so if we have a rule like this, x implies y, the confidence of that rule is support by support of x. Now for that we need to know what is support. So support is another measure. So we have two measures, or rather three we can say, support, confidence and lift of a rule. एक rule होगा, rule के लिए we need to have we can measure that rule based on some measures. Okay, one is the support. So what is that support? Here, milk, bread and butter has a support of 1/5. That means out of all the transactions, how many times milk, bread and butter have been bought together. Okay, so let's see this particular database here. See, how many transactions are there? 5. So the denominator is 5. And how many times milk, bread and butter have been bought? See here, 1, 1, 1, this one. So only once. See, anywhere you don't find all the items being bought together. Only 2 or 1 or none have been bought. So here in the fourth transaction, we found that the 3 items have been bought together, and that is only once. So it is 1/5. So it is the support of this particular rule, which says, what does it say? Which says whenever bread and butter are bought, customers also buy milk. So whenever I say that the support for that particular rule is just 0.2, that means out of 5 transactions, only one such transaction has happened. Okay. Okay. Next, the confidence. The confidence of the rule says that it is the support of x union y divided by the support of x. Okay. So it says out of how many transactions that consisted of bread and butter, from that number, how many have bought milk, right? So how many transactions are there which consisted of bread and butter buying together? So let's see, only bread and butter buying together. So we have
One, I guess.
Yeah, only one. But then you can just replace with the formula support of x union y. What is x? X is on the left hand side of the rule. So left hand side of the rule is bread and butter. So bread and butter as well as this milk together. Okay. See, bread and butter as well as milk together. That means all the three. All the three, uska support. That support is already found here. It is 0.2. So in the numerator we will have 0.2 here, as this is given 0.2 divided by the denominator. Denominator is the support of x. Support of x is the left side of the rule. So the left side of the rule is here. The left side of the rule is bread and butter. Okay. So again, support means out of all the transactions, matlab out of 5 transactions, bread and butter have been bought together how many times? Only these two we have to see, bread and butter, bread and butter, only once again. Are you following? So it's again 1 by 5.
Yes.
So support of x is 1 by 5, support of x union y is also 1 by 5. So it's 0.2 by 0.2, it is 1. So the confidence of x implies y is 1. So x is the left hand side of the rule and y is the right hand side of the rule. So the rule is like this. So it could be anything. We can frame any rule, and based on that, we can find out its support as well as its confidence. Okay. Now, after having found out the support and the confidence, we can put a threshold and then decide whichever rule meets that. Say, suppose we have a test out of 100 marks. We say that whoever gets more than 40 are passed and whoever gets less than 40 are failed. So we have decided 40 as the threshold or the pass marks. It always need not be 40. We can tell 50 is the pass mark, 60 is the pass mark, depending upon our need, depending upon the organization. So here also, depending upon the application, etc., we can set a threshold, and all rules that pass that particular threshold may be called as a strong rules, whereas the rest of the rules may be weak rules. Okay, we'll come to that. Then again, there's another formula called lift of a rule. Again, the formula is given. Based on that, you can just check it out. Okay, I'm just leaving that. And then again, another one is there, the conviction of a rule. So as we have 3, the fourth one is conviction of a rule. So every rule has got support, confidence, lift, and conviction. Okay. Okay, now this is important. Market basket analysis. These rules and those support and confidence will help us in performing the market basket analysis. So what do we mean by market basket analysis? It says that whenever a person goes to a market with a basket, then what are the things that he buys together? So is it milk, bread, cereals, or milk, bread, sugar, milk, bread, eggs, etc.? So those are the things that we will keep or put them together in the shelf so that they get sold quickly. Okay, so that is what is our aim. So that is why the name is market basket analysis. So we are going to perform the analysis using something called frequent pattern analysis. Again, this also means the same thing. It says what are the frequent items that are being sold that we have to analyze using algorithms, and then accordingly we have to go for marketing. Oh, sorry. Okay, so how are we going to analyze here? Frequent pattern mining, that is, which patterns or which items are bought frequently. They can be classified based on various criteria. So based on the completeness of the patterns, maybe based on the levels of abstraction. Levels of abstraction is, give me a moment. Okay. Levels of abstraction is one thing I'm showing you, like maybe this is a rule. This says that if X buys a computer, implies X also buys a printer. Naturally, if we buy a computer, we will need to take printouts. So there is a very much chance that we also will buy a printout. Okay. So similarly, we may buy, if we buy a mobile phone, there are chances that we will buy a cover for the mobile phone as well as a screen guard, etc. So how much possibility is there? That is to be taken care of. Maybe the confidence and the support is going to tell us how many people are going to buy the screen guard or the cover along with the mobile. So similarly, this is a rule that says whenever X buys a computer, he also buys a HP computer. He also buys a HP printer. Now, the levels of abstraction is, if we go deeper into the thing, instead of computer could be a desktop, could be a laptop, etc. Yes, mobile phone, charger to milta hai na, nobody is going to buy, Shreya. So, am I right?
No, Mac one.
Charger to
For
mil jata
iPhone.
hai na.
For
तो
iPhone, we have to buy that.
आईफोन के लिए चार्जर क्यों? Charger is available with every phone, right? Maybe earphones sometimes are not available with the phones. iPhones, earphone is available, but with other phones, earphones are not available. So that also could be taken into account. So here I was telling the level of abstraction is, here generally it is being told computer, but then under computer it could be a desktop computer, a laptop computer, and of different sizes. So it has been specifically told. So if it is a laptop, that is the levels of abstraction. If we go deeper into the rule, okay, that is here. That is what this is, at a higher level of abstraction. This is at a lower level of abstraction. Then depending upon the based on the number of data dimensions involved in the rule. Data dimensions means, okay, single dimension means here both buys and buys. This is a multi-dimension. That is, we are including age, income, and then buys. So what does this rule say? If X ka age is in between 30 to 39 and his income is between 42 to 48K, then X buys a high resolution TV. Naturally, income itna hoga, and then age, matlab, see, both are related. If age is in between this, naturally income will be this, and naturally when he gets more money, he will try to have more luxury things, and then he will buy the high resolution TV. So these are the things that we generally see and accordingly frame the rules. So why are we actually framing these rules? We frame these rules so that on our part we can easily see this, but when there's a huge amount of data, even we cannot scan each one of them and see. So we have to train the computer. We have to train the computer so that it will pick up this, according to these rules, it's going to pick up the information for us and analyze for us. So we have to teach. So if we have to teach, we have to, how are we going to teach? The way we are going to analyze, we have to frame rules accordingly and then teach the system. Okay. So that is how things are there. And then based on various other things, we are going to mine the frequent patterns. Frequent patterns means which two items will go frequently together. Okay. Now the basic algorithm or the important algorithm is called a priori algorithm. Okay. So I'll just show you how it does. This is the algorithm. Okay, the example is given over here. This is a standard example that you will find in any book, and the main textbook that you can deal with is data mining concepts and principles, and it's by Jai Hawaii. So it's a foreign author, but it's a very good book, and this example is also from there. So all the diagrams and all whatever I have shown is from that book. And if you have time, if you go through that book, it's very it would be very nice. In simple language, it has been explained everything. So it's very nice one. Okay, see. So first of all, this information will be given to you. So how are we going to generate the patterns based on the algorithm? So let me tell you the algorithm, explain the algorithm along with the example. See, we have got 9 transactions with the names T100, T200, T300, and so on. And there are items, instead of giving bread, butter, jam, etc., the names of the items are given here as I1, I2, I3, I4, and I5. And in transaction 1, we have these are the 3 items that have been bought together, I1, 2, 5, next is 2, 4, and so on. Okay. Now, so how many transactions are there? 9 transactions. D is the database, and the size of the database is given is written as D mod, and that is 9 transactions. Okay. Now, you can just read all these things. I'm just explaining it. Yeah, see, this is how you have to find out at each step. Now, I would actually want you to write this down, because I have to move this to back and forth. Just note down this thing. Just note down this thing so that whenever I tell you, you can tell me the values and you can verify. Instead of T123, something you write down, just it's identification. T123, you can just write them. These things note down correctly. I insist that you note down, otherwise you won't be able to understand this algorithm. Okay, if you have noted, just let me know. The other two, Aman and Shreya also. Okay. So let me scroll. Okay, Aman, is it done? I'm scrolling it.
Yes, ma'am.
So I'm not seeing that. You only have to tell me whatever I ask. Okay, see. So how many items are there? You have to prepare this table. Okay. So how many items are there totally? You see that table and tell.
9 transactions. I think the items are 5.
Yes.
I1, I2, I3,
I4,
I5.
I5. Okay. So first, this table has to be prepared like that. Yeah, like whatever items are there, that many items you have to write down like this. Okay. Then
Okay.
here, what is the support count? That means in how many transactions I1 has occurred. Just tell me, check that thing and tell me. I1 has occurred in how many transactions?
Transaction 1.
Count.
In 6 transactions, it has I1 has occurred.
Yeah, see, that is what is written. So just check for
Yes.
I2 and 3. No need to note down. Just now, you just see that. Anyhow, this document will be sent to you. You can do that later. Okay, so
Okay.
check these things whether these are correct or not.
Yes, ma'am. Almost it will be correct. I think. Yes, it is
Yeah,
correct.
okay, fine. So you have understood. Just check randomly 2 or 3. You can just check. So understood now. So
Yes,
what you
ma'am.
have found is, first of all, just select one item set. One item set means, see, within brackets, it's a set. So within brackets, you have put a set. I mean to say, you have to write down a set with single items. Okay, so we have 5 items, so you have to write this down. See, scan the database for each count of each candidate. So 5 here, so 5 you have to write down the set, and this I1 has occurred in how many transactions, that you have to note down. Okay, next. Next is, in our question, it must be given somewhere. It It must be given somewhere that the threshold I was telling now, like out of 100 marks, 40 is the pass mark. Who has decided that? Suppose in the our organization decides ki it's not 40, it's 50. So it depends from organization to organization. So that support, whatever we are counting, that minimum support is 2. That is given in the question. So next thing is, after having found out this, we are going to pick up only those rows which will meet that minimum support. Any row that is less than that minimum support is to be discarded. But here, all of them meet the minimum support, so all of them will go to the next level. So next level is here, compare the candidate support count with, this is the candidate support count with the minimum support count. Minimum support count is 2, so all of them are equal to or greater than 2. So they will be moving on to the next step. So the next step is called L1. This is the candidate set. This is the L1. So from this, yeah.
How the minimum count set is 2 means where did you get that number 2?
No,
Minimum?
that will be given in the question. That will be given in the question. That will be decided by the organization or whatever.
Okay.
Like whenever we are starting the priori algorithm, depending upon the application, etc., we have to decide on that, and that will be supplied along with the database information. That is also given. If that is not given, you can take something on your own and accordingly start working on this algorithm.
Okay.
So 2 is there. So all of them meet the criteria. So you get another set called L1. Now from L1, you have to make another candidate set, that is C2, and then again repeat the same process. But then how are you going to make or create C2 from L1? That is to be understood. So here, so generate C2 candidates from L1. How? So just combine the first item with all the other items. So I1 with 2, with 3, with 4, with 5. Okay. Then I2 with the rest below it. So I2 with 3, with 4, with 5. Then I3 with the rest below it. So I4, I4, 5. That's it. Okay. I3 with 4 and 5, then I4 with 5 alone. Is it clear?
Yes, clear.
So you got C2. Now, after getting the items in the C2, find out their support count. So how many times in that database I1 and I2 have occurred together? Just check that. Check these values. Any just randomly check these values in the database that you have written. Both the items should occur together. How many times they have occurred? That number, is it correctly there or not?
Yes, ma'am, it's correctly there.
Okay.
Now,
so once this is done, again, now from this C2, you have to get L2. How? Minimum support, those rows which do not satisfy the minimum support, just remove them.
okay.
So here, this one is removed. This one is removed and these 2 zeros are removed and rest of them have been put.
Okay.
Again, similarly, from L2, make C3. Then again, find out its support count. Then make L3. Then its support count. So finally, see, again, one more thing you have to understand how you got this. This C3 is obtained from L2 and L2, right? So what will happen? This is how you have to perform the cross product here. These are the items, the completely, we have it in what? C3 is L1. Nothing but L2 join L2. So this is L2, the complete thing. So whenever whenever we are joining this complete thing with this, it should be join this join this, the first one joined with all the items, the second one joined with all the items, and so on. But just remember one thing, it's not so easy. The earlier one happened to be so easy, but then what you have to note down one thing here, it's all are written. I'll just show you one thing. See, uh, the two item subsets of I1, 2, 3. So here you get this. Anyhow, whatever I've told earlier, that the first one is to be crossed with all the below, the second one with all the below, and so on. So when you cross this, cross means cross join. Okay, when you perform the cross product of this and this, you get these things. Okay, but you have not put all of them. You have not put all of them here. You must be thinking, there are, see here what happened, 5 are there and we got so many things, but here also almost 5 are there, 1 2 3 4 5 6 are there, but then how did I get just 2? Okay, so when we do the cross product, you get so many, you get so many elements, but then the next thing that is to be checked here is this item or this item will be there if its subsets are also frequent. The subset L1, L2, L3 are frequent item sets. And we have to generate, in this particular algorithm, we have to generate the frequent item sets. That means which items are bought together, which two items are bought together, that is L2. L3 is which three items are bought together. So that we have to find out. So L2 and L2, we will, when we go for the cross product, we will be getting the candidate set. From that candidate set, what we have to see is, if we are going to pick up I1, I2, I3, the subsets of this should also be frequent. That means the subsets of this should be there either in L1 or L2. If they are not there, then this cannot be there in L3. Say for example, I1, I2, I3. What are the subsets? I12, I13, I23, and I123. So naturally, I123 will be there in L1. So these are the two item sets that are the subsets of this, and they are all there in L2. Because they are there in L2, we will keep this in C3. Am I clear?
Yes, ma'am.
So let's see another one. Suppose I125. I125, we are not considering one item set, because one item set may everything is there, so no need to write down here. Say two item set. Here again all are there, so we have put it here. This is the one. I135 may we have 1 3 1 5 3 5, but 3 5 is not there in L2 because 3 5 is not there in L2. This particular thing, this whole thing, we will not keep in C3. So that is why, even though we have so many items members here, 1 2 3 4 5 6, we have just selected 2 of them because the subsets of these are there in L2. Okay, so that way we have to select, and finally when we cannot select anything, we get an empty subset, we are going to stop. So that many frequent item sets will be generated, L2, L3, and it got stopped. L4, we did not get any items in the L4. Okay, so now what are we going to do? The way we have selected, that is called the a priori property. We are going to pick up an item and put it in the frequent item set only when its subsets are frequent. That is called the a priori property. What is a priori? A priori means something is known beforehand. So we know that is frequent item set. It is a frequent item set if its prior ones, if its subsets are also frequent. That is called the a priori property. Okay. Now, how are we going to generate the association rules from this frequent item set? The algorithm is not complete. After having generated the frequent item sets, then we are going to generate the rules. Okay. So here, this is the one. These two are the important. For each frequent item sets L, generate all non-empty subsets of L. Okay. Then for every non-empty subset S of L, the output the rule. That means from the frequent item set, we have to generate the rule. Okay, how are we going to generate the rule? Item set is L. We have to find out all the subsets. For every non-empty subset S of L, the rule will be like this. S implies L minus S. Only if the support of this is greater than the minimum confidence, etc. Let's see the example. See, we have taken one L. See, in the frequent item set, what is left? Here. After like at the end, at the last stage, we are left with these two frequent item sets in C3. Okay, so we are picking this. Whatever we do for this, the same thing we will repeat for this also. So we are taking I1, 2 and 5. So here, I1 to 5 is L. See this particular thing. For each frequent item set L, generate all non-empty subsets of L. So L is this. Generate all the non-empty subsets. I1 to 5, then 1 to 1, 5, 2, 5. Okay. After having generated that, then the next one here. For each non-empty subset, for each one of them, 1, 2, 3, 4, 5, 6. So we will be generating 6 rules. How? The rule will be like this. Implies on the left hand side S will be there, on the right hand side L minus S will be there. We know what is S, we know what is L. So we have to just put them. See here on the left hand side we are going to put S. So if we take this one, first one, this is S, this is also S, all of them are S. Just see all the left hand sides of this rule. On the left hand side of the rule we need to have just S, and this is the subset I12. I12 means 1 and 2 here. Next is 1 and 5, next is 2 and 5, next is just I1, I2 and I5. Understood? Next, implies. After implies, what do we have? We have L minus S. L minus S means L is all these three. If we remove the first two, whatever is left over is on the right hand side. So 1, 2 is already here. So put 5 over here. 1, 5 is here. So put 2 over here. See this one. 1 is over here. Put 2 and 5 over here. So I believe this is understood. How to generate the rules? Once you have generated the frequent item sets. For each frequent item set that has been generated at the end, this has to be done. So this is done for I1 to 5. Similarly, here for I1 to 3 also we have to do. Now it's not over. Generate this rule if the support count of L and S is greater than the minimum confidence. To generate the confidence, that is support count of L and S, support count of L. This is the left hand side is L. Sorry, this rule is L. So the support count, you just check that table I1 to 5, how many times they occur? Support count means how many times they occur. I1 to 5 together.
2 times.
2. So here it says the support count of L. Suppose this one, support count of L. L is the same. L is the same. So the numerator of all this is 2. Now the support count of S. S differs. So now check what is S over here. S is the left hand side of this rule that is generated. So S is I1 and 2. How many times they occur? Or you can see S from here also. Okay, I1, 2, how many times they occur? That becomes the denominator.
4 times I1 and 2.
Yeah, so this is 2 by 4 and that is 50%. Similarly, just check this one. Just we'll check this one. S is, this one means S is on the left hand side. I1 occurs.
Six
You can
times.
see the first, yes. Instead of counting also, you can see the first table, C3. That also you can be checked. Okay, so it occurs 6. So 2 by 6. So finally you get these percentages. That is called confidence. Now what is it told? Support count of L by support count of S is greater than equal to the minimum confidence. Again, minimum confidence will be given to you in the question. So if suppose we say it is 50%, okay, so anything greater than 50%, that means this rule and this rule will be taken into account, or they'll be known as the strong rules. Fine. So association rule mining, in that particular topic, we try to understand what two things are associated together or go are bought frequently, or what are the frequent item sets, or what are the frequent items that are bought together and they form the frequent item sets. And to know that, this is the best algorithm, a priori algorithm, that is known as a priori algorithm, because we are trying to find out the frequent item sets based on the prior knowledge, based on the prior frequent item sets. And it consists of just two parts: first generating the frequent item sets, and then generating the association rules out of it. And remember, and how are we going to measure the interestingness of the rules, whether they are strong rules or whether we are really interested in that rules or not? By measuring the confidence and the support. And confidence is, of course, includes the support. Am I clear?
Yes, ma'am.
Okay. Okay, it's going to be 8. This algorithm is basically meant for mining single dimension association rules. Okay. Now, if we have a multi-level association rules, then how are we going to mine it? Say, for example, we have a store that consists of all electronics. It consists of computer, software, printers, computer accessories. Computer could be a laptop, desktop software could be an office software, antivirus, and so on. Okay. If that is the division, or called the concept hierarchy of how we have divided. So this is the general level. A little more deeper into it, a more specific and more specific. If it is a laptop, again, it could be an IBM, Dell, etc. Similarly with a desktop and so on. Different levels we have divided. So how are we going to mine the rules? So here, by the first method is uniform minimum support. Uniform minimum support means we will put minimum support for each level. Okay, so the support value is given at each level. Say this is a portion. This portion is a portion of this one here. Only ye wala. The computer, laptop, and desktop. Only this much is shown out of the complete hierarchy. So if there are different rules of selecting. So level 1 and level 2, we will put minimum support as 5% only. That means we will put same support for each level. That is one technique. So then what will happen? This one is not going to be selected. Desktop is not going to be selected. Laptop and computer is going to be selected. Reduced minimum support, which means as we go deeper into deeper, we are going to reduce the support level. Okay, here this is 5, and then when we go deeper into the levels, we are going to reduce it to 3. Whatever be the case, that see here what happens is, say I'll give you an example of a test. I have put 100 marks of test, and 100 people have appeared the exam, and I put a pass mark of 90. So how many students will I get? So maybe very few, but if I put 10 marks, then I'll get so many. So what should be the right one? So it depends. So maybe in campus interviews, when people come for campus, so they put some criteria, maybe 70 or 80. When they find that very few people have passed, then they're going to lessen the criteria so that more people will come. So what is correct is to be decided by the application, is to be decided upon the data, etc. So that is what is told. So if you put a more strict support, then you will be missing interesting patterns. But then if you put very less, then you will be getting more junk data, and then it's of no use. Okay, so that is, you have to balance in between them. Okay. Okay, so that was one of the criteria, functionalities of data mining, which is association rule mining, and one of the important algorithms was a priori algorithm. Similarly, classification and prediction is another important topic in data mining, and for here again we have algorithms. I believe we will take up in the next class. Um, any doubts?
No, madam.
Okay, so just go through this, and in the next class we will discuss that. I don't know how many classes will be given, but let's see. Accordingly, we can plan out. And once you have got a base or the overview of the subject, you can also read on your own. Maybe go through videos on this particular topic so that you can understand. Else, you can also ask or take my help in the subject anytime. So one of you can text me so that I can save your number in case I have to contact you anytime. Okay. So that's it for today. Thank you. Yeah, send your